Okay, in this lesson, we'll talk about multiple load connection. In multiple load connection, we'll have to recall basic concepts about simple circuit. With simple circuits, we have the following circuit elements: a voltage source, a resistance, and the connecting wire, or wires. In a simple circuit connection, it follows what we call Ohm's law. With Ohm's law, we relate three variables: voltage, current, which is represented by I, and resistance R. The equation is V is equal to I times R. For multiple load connections, we have two examples: a series circuit and a parallel circuit. First, we'll focus our attention on series circuit and describe the following characteristics. First, in a series circuit, resistances are added. So if there are two or more resistances, we simply add R1 plus R2 and so on. With voltage, voltage gets divided in the circuit elements. For current, current are equivalent. That means current 1 is equivalent to current 2 and so on. That means if there are more than two circuit elements here, you'd have equivalent currents for all of those. For parallel circuit connection, the following are the main characteristics. First, to get the total resistance, 1 over R equivalent or total resistance is 1 over R1 plus 1 over R2 plus 1 over Rn. That means if you have several resistances connected in your circuit, you can use this formula. For voltages, the voltages in all circuit elements are the same or equal. Current gets divided in a parallel circuit. That means the total or the equivalent voltage here that we'll be getting, we can use Ohm's law and compute for the current equivalent, and that current equivalent here will be the sum of the currents in the individual circuit elements. We can try an example problem to solve, and we'll start with series circuit. In solving problems involving series circuits, it's important for us to be guided as to what are the given in the problem. Say, let's consider the following given. Let's consider R1 is equivalent to 2 ohms, R2 is equivalent to 3 ohms, and the total or the equivalent voltage is 10 volts. In order for us to solve this problem, we should note the following. First, let's consider what are the given in the problem. We know that there are 3 that are given in the problem. We are given R1, which is 2 ohms, R2, which is 3 ohms, and the equivalent voltage or voltage total, which is 10 volts. So since we're already familiar as to the given, we can start solving. First, we can solve for the R equivalent. We have to recall our basic characteristics or the basic characteristics of circuits in series. That in order for us to solve for the total resistance or the equivalent resistance, we simply add. That means R1 plus R2 will give us the value of our R equivalent. So the values are 2 ohms and 3 ohms. That will give us an R equivalent of 5 ohms. Since we're already done solving for R equivalent, we can encircle that in our guide and note for some others that we can solve. Here, we know that we know R equivalent and V equivalent, so we can use Ohm's law, which relates voltage and current and resistance in an equation, and solve for I equivalent. So to solve for I equivalent, we simply manipulate the equation and solve I equivalent equals voltage equivalent divided by R equivalent. We note that the given voltage equivalent is 10 volts. We simply substitute the value 10 volts and divide it by what we have calculated for the R equivalent, which is 5 ohms. And that will give us a current equivalent of 2 amperes. Again, we refer back to our guide here. We're now able to solve I equivalent. So we encircle this. And we use another big idea or characteristic of circuits in series. And that big characteristic is this one, that the current are equivalent in all circuit elements in series. That means whatever the value is for I equivalent, that will be equal to the individual currents I1 and I2. That means, in our guide, we can encircle 2 more of what we are to solve, I1 and I2. From our guide, we can note that there are 2 remaining values that we can solve, or we are about to solve. Those values are for V1 and V2. In order for us to solve V1, we once again use our Ohm's law equation, V1 equals I1 R1. We note that the subscripts are the same. To refer to the first circuit element here, R sub 1. We simply substitute the values I1, which we have already calculated, 2 amperes. The resistance 1, which is 2 ohms. And multiply. Get 4 ampere ohm or volts. So we're able to solve V1 already. We now can encircle that and solve finally what the value of V2 is. We simply follow the same process, V2, I sub 2, R sub 2, that is, we use our idea from Ohm's law, which tells us that voltage is equal to the product of current and resistance. Substitute the values. Current 2 is equivalent to 2 amperes. Resistance 2 value is 3 ohms. And multiply. We get 6 ampere ohm or volts. So from our guide here in solving multiple load connections, we now can note that we are able to solve all of the unknowns. And in order for us to check if we're able to really get the values correct, we can recall from the characteristics of circuit elements in series that the voltage equivalent must be the sum of the individual voltages. That is, V equivalent should be equal to the sum of V1 and V2. We recall from our calculation that we're able to solve V1 to be 4 volts and our V2 to be 6 volts. So upon checking, we can add 4 and 6, we get 10 volts as the equivalent resistance. To validate the value, we look back at our given V equivalent is equal to 10 volts. So we've confirmed that we're correct. The second example that we can consider is for parallel circuit. So for parallel circuit, we can use the same example values. The values of which are, again, this one. Voltage total is equivalent to 10 volts. Resistance 1 is equal to 2 ohms. And resistance 2 is equivalent to 3 ohms. And in order for us to solve problems related to this, or this particular problem that we have here, we once again should be guided by our list of possible values here. And in order for us to solve this, we shall once again recall our guide for the big characteristics of parallel circuit connections. First, we can encircle those that are given in our problem, R sub 1 and R sub 2. We are also given our equivalent voltage, and we can start solving. Just like before, we can start our solution by solving our R equivalent. In solving R equivalent, we simply follow the equation 1 over Req is equal to 1 over R sub 1 plus 1 over R sub 2, since there are only 2 circuit elements given. This equation follows this feature for parallel circuit elements. We simply substitute the values. 1 over our R sub 1 here is 2 ohms plus 1 over our R sub 2 value here is 3 ohms, and add. The least common denominator here is 6. And then 6 divided by 2 here is 3 times 1 is 3. Plus 6 divided by 3 is 2 times 1 is 2. And we note our unit. So this is ohm here and this is ohm squared here. So this results to 5 over 6 ohm, because this one will be cancelled. So the resulting R equivalent will be the reciprocal of this value, which is 6 over 5 ohm. So we're able to solve for the R equivalent, and we can now encircle that value here in our guide. Since we're done solving for R equivalent, we can now solve for I equivalent. So we know that this and this, we can use those values to solve for I equivalent, following Ohm's law. Once again, following Ohm's law, we can solve for I equivalent by manipulating our equation. So I equivalent is equal to V equivalent divided by R equivalent. We substitute the values. Our value for voltage total, or V equivalent, is 10 volts. Simply substitute 10 volts here, divided by the R equivalent that we were able to calculate, that is 6 over 5 ohms. And from this, we can solve 50 over 6 volt over ohm is ampere. We simplify the value. 50 over 6 is 25 over 3 ampere. From here, we're now able to solve the I equivalent to be 25 over 3 amperes. And we refer back to our guide here and circle this and say that we're already done solving for I equivalent. Next, we can note that one of the features of circuit elements in parallel, voltages are equal. That means to say that whatever the voltage equivalent is, that will also be the value of the V1 here and the V2 here. That means we can now note that V1 equals V2, and both of these are equal to V equivalent. And the value is 10 volts. So we once again refer back to our guide here and encircle what we were able to note, that the values of V1 and V2 are both equivalent to 10 volts. This means we're only left to solve I1 and I2 here. And in order for us to solve I1 and I2, we once again use our idea of Ohm's law here. That is, in order to solve for I1, we manipulate this equation and solve V1 over R1. The value of V1 is 10 volts, and the value of our R1 here is 2 ohms. This gives us a value of 5 amperes. Finally, we solve for I2, which is V2 over R2, following the same process. We substitute 10 volts divided by our R2 here is 3 ohms. And this gives us a value of 10 over 3 amperes. Which means to say that we were able to solve all of these values already. And in order for us to check if we're able to solve all values correctly, particularly checking if current really gets divided, we simply add the two values of current here and check if we will be able to get our I equivalent, which is equivalent to 25 over 3 amperes. Let's check. We check if I1 plus I2 will give us our I equivalent. We substitute the values here. That's 5 amperes plus 10 over 3 amperes is I equivalent. And this gives us a value of 25 over 3 amperes. And that's it. In this lesson, we were able to learn about multiple load connections. Particularly, you were able to learn about parallel circuit connection and series circuit connection. Thank you.